All right, so ladies and gentlemen, I apologize that this is just now getting put on Canvas. I've had some technical difficulties over the last couple of days and I haven't been able to record, so I'm doing it old school on the iPad. So I apologize that they're still handwritten, but they're not going to be as neat. So I apologize in advance. Okay. Also, side note, if I get random text or notifications, they're going to pop up, I think, right where the picture is. So this could be fun. So let's go ahead and look at these notes. We've already solved systems by graphing, and we've solved systems by elimination. So now we're going to actually solve systems by substitution. Okay, so solutions to systems, remember, I'm going to zoom in here. Solutions to systems are points like x, y, okay, that both equations or lines have in common. They're also systems, or I'm sorry, they're also two numbers told you this would be hard. Two numbers that satisfy or work in both equations. Okay, so those are just solutions to systems. Okay, so substitution. What exactly does substitution mean? So by definition, substitution is replacing one thing with something else. All right, so let's see if I can do this instead. Replacing one thing with something else. That works a lot better than me trying to write it, right? Okay, so that's the definition of substitution. So what we're going to try and do is we're going to substitute or replace one thing with something else. Okay, so what exactly is the substitution method? So it's just a method for solving systems of equations where one equation is substituted into the other to eliminate a variable. Okay, so how do you use the substitution method to solve a system? Okay, so we're going to go through these steps real quick, and I'm going to probably end up typing because I can't really write. Okay, so step one, we're going to solve make that. Can you tell? Select all. Okay, so we're going to solve one equation for x or y. Okay, if one isn't already equal to a variable. Okay, so we're only going to solve one for x or y, but we're only going to solve it if one isn't already equal. So like if it doesn't say x equals or y equals or something like that. So special note, if there is one with a coefficient of 1, solve for that variable. That right there will make it significantly easier for you. Okay? Step 2, substitute the expression for the variable from step 1 into another equation. So we're going to plug in I don't like that it makes me do this for all of them. And I want to make it a different. Oh, that's fine. Whatever. Plug in what the variable from step 1 is equal to into the other equation. Okay. When you plug in, you want to make sure you use parentheses because otherwise you could do something wrong and you might distribute incorrectly. Okay, so after we plug in, we're going to solve. for the one variable that remains. Okay. Step 4, we're going to plug in or substitute the value from step 3 into the equation from step 1 to find the value of the other variable. Step 5, solve. Write your solution as an ordered pair. Okay, and we can always check when plugging in. Okay, so we have some special cases. Of course we do. Okay, so some of our special cases have to do with no solutions and infinitely many solutions. Okay, so when, there we go, the variables cancel, or when they add to 0, and you're left with, okay, so this is the key, we either are left with a false statement, so like 0 equals 10, or we're left with a true statement, so like 2 equals 2, okay? So if we're left with a false statement, there are no solutions. If we're left with a true statement, there are infinitely many. Okay? Cool. So let me show you what I mean. All right, so first equation, we have x plus y equals 2 and y equals 2x minus 1. The first thing I notice is that this equation right here, okay, is already solved for y. So we have this y equals. All right, so we're good to go. All right, so what we're going to do is we're going to take this whole equation, okay, and we're going to plug it in for y. So these two y's are going to like take the place of, okay? So I'm going to take this thing, 2x minus 1, and plug it in for that y. All right? So this is what it's going to look like. Okay, so we have x plus y equals 2. I'm sorry, you're getting a great view of my forehead. And so when I plug in for y, I'm going to replace that y with 2x minus 1. So it'll look like this. X plus 2x minus 1 equals 2. So now I have a pretty simple algebra problem that we're going to solve for. There's nothing to distribute, so we're going to combine like terms. X plus 2x minus 1 equals 2. So when I combine my like terms, these are the two x's that I have. Okay, and so when I combine these two things, x plus 2x is 3x minus 1 equals 2. 3x equals 3. So I added 1 to both sides. For those of you who are like, what did she do? I added 1 to both sides. So that's how I got that. Oh, we're at the end of the page. So to get x, I'm going to divide by 3. So x equals 1. Okay, so that's great, but now I have to solve for y. Okay, so when I solve for y, I'm going to pick one of the equations and I'm going to plug the x value in. So I think it's pretty easy to pick which one I want to solve for y. I'm going to plug it into this equation right here, that second equation, because it's already solved for y. Okay, so we're going to go ahead and we have our y equals 2x minus 1. So we're going to take this baby and we're going to plug it in for x. So we get y equals 2 times 1 minus 1. Okay, which is the same thing as 2 minus 1. Wah, that's a 2. I promise that's a 2. So y equals 1. Okay, but we need our solution to be in the form of an ordered pair. So 1, 1. There's my final answer. Okay, that's an example of substitution. Okay, so let's move on. I believe I have some more on the back. I have a lot more on the back. That's a lie. All right, and they're all substitution. So, okay, so we have 2x minus 3y equals 12 and x equals 2y plus 7. So, again, first thing I notice is that the second equation here is already solved for x. So x equals something. So I'm going to go ahead and I'm going to plug this whole 2y plus 7 in for this x value. Okay, so they're literally going to swap places. All right, so we're going to take our 2, and then I'm going to use parentheses, 2y plus 7 minus 3y equals 12. Okay, so now we're going to solve for y. We can get y entirely by itself. So step 1, we're going to distribute. Okay, remember distributing, we just multiply everything inside the parentheses by whatever number is directly outside the parentheses. Okay, so we're going to multiply 2y by 2 and 7 by 2. So we end up with 4y plus 14 minus 3y equals 12. So again, we combine like terms. So the y's I'm going to add together because they're on the same side of the equal sign. So we have 4y plus negative 3y, which is the same thing as y. So y plus 14 equals 12. So y is equal to negative 2. So now that I know that y is equal to negative 2, I need to solve for x. So I'm going to go and I'm going to plug it in to our second equation because we already have x equals. Okay, so we have x equals 2y plus 7. So I'm going to go ahead and plug in that negative 2. Okay, so x equals negative 4 plus 7, x equals 3. Right? Yeah. Okay, so my solution is 3, negative 2. Okay. Oh, really need to crack my neck. Okay. So the next one. So looking at number 3, the first thing I notice is that not a single one of them is solved for a variable yet. So I'm going to pick which one I want to solve for a variable. Which one do I think would be the easiest to solve for a single variable? Okay, and I notice that the x doesn't have a coefficient in front of it. It's just straight up x. Okay, so I'm going to solve that one. Sorry guys, it's time to leave school. So I'm going to solve this equation right here for x. Okay, so we have x minus 3y equals negative 1. So I want to get x by itself, right? That's all I want to do. So I'm going to go ahead and I'm going to add 3y to both sides. So I get that x equals 3y minus 1. Okay, so now that we have it solved, I'm going to go ahead and plug it back in to this second equation here. Boom. because we can't plug it back into itself. All right, so we're going to plug it into the other equation. So that other equation is, we have 2x minus 3y equals 4. So we 3y minus 1 minus 3y equals 4. So we go ahead and we distribute that 2 all the way through to everything. And so we have 6y, oops, sorry guys, 6y minus 2 minus 3y equals 4. Okay, so we combine like terms. So we have the 6y and the negative 3y. So when I add 6y and negative 3y, I get, here, let me do this so we don't get confused. I get 3y minus 2 equals 4. 3y equals 6. Y equals 2. Equals 2. Y equals 2. Okay, so now that I know my y value equals 2, I need to solve for x. Well, we got lucky because now we just have to plug it in there because I already know what x equals. Okay, so it's like this huge big circle, all right? So x equals 3 times 2 minus 1. So 6 minus 1, x equals 5. So my solution is 5, 2. Okay. All right, so let's look at number 4. All right, so same idea as number 3. They're not solved for a single specific variable, so I need to find one and solve for a single specific variable. Okay, so I notice that the second equation has a plain old y. Okay, there's no coefficient, it's just straight up y. So let's solve it for y. Okay, let's get y by itself. So we're going to go ahead, take this equation, and get y by itself. So y is equal to 3x plus 6. Cool. Okay, so now that I manipulated and I played with that equation, what was on the floor? Okay, I can tell my priorities are back. Got my blanket. I'm going to plug it into the top equation. All right, so this equation right here, we're going to take it, plug it in to that top equation. All right, so we have negative 2x plus 4y is 14. So it's going to take the place of the y, so we have negative 2, negative 2x plus 4, parentheses, 3x plus 6, that should be a 14. Okay, equals 14. Okay, so we distribute. All right, so we have a negative 2x, that doesn't change, plus 4 times 3x is a 12x, 4 times 6, 24. Equals 14. So we combine like terms, so there's our 2 that have the like terms, so negative 2x plus 12x gives me a 10x plus 24 equals 14. So 10x equals negative 10, so x equals negative 1. We know what x is, so we plug it in so we can solve for y. Okay, so y equals 3 times negative 1 plus 6. y equals 3. Okay, so my solution is -1, 3. All right, I'll leave the last two up to you. You're welcome to try number 6. I don't think I'm going to throw any story problems at you, and if I do, on your next test, I'll give you 4 more. Okay? Let me know if you have any questions.